Today's lesson, we're going to look at ionic formulae. So what we need to understand is what charge the different atoms form when they turn into ions. So there are certain ones we can work out from the periodic table. There's certain ones that you should just memorize. I will make those clear. So in group 1, they have 1 in the outer shell. So is it easier to lose 1 or gain 7? We've already discussed that metals lose is easier. So this will form a charge of +1. This will lose 2, so it'll be +2. The transition metals we don't need to worry about. This will be +3. Now, carbon, we don't deal with group 4 normally. They don't form ions, so we don't need to worry about it because you can either gain 4 or lose 4. Technically, it's equally likely. So for now, we can either leave it blank or we can put +4. Now, when we get to 5, we need to think about how you reach 8. It's easier to gain 3 than lose 5. So it gains 3 negatives, becoming -3. Group 6 gains 2 negatives, and group 7 gains 1 negative because you need to get to 8. So 7 + 1 is 8. And group 8 or group 0 has 0 because it has no charge. It does not form ions and is inert, unreactive. It doesn't need to gain or lose because the outer shell is already full. For example, helium has 1 shell with 2 electrons in it. 2 is the maximum allowed in the first shell, so it is perfectly happy as such. Now, let's look at the pattern. +1, +2, +3, +4, -3, -2, -1, 0. Another way to think of it is just subtract 8 from once you get to 5. So 5 - 8 is -3, 6 - 8 is -2, and 7 - 8 is -1. That's just a way you can do it. Now, the power of this tool is that you now know the charge of any of these. So if someone asks you for rubidium, you know it's +1. If they ask you for astatine, it's -1. If they ask you bismuth, it's -3. If they ask you calcium, it's +2. Now, you should be aware of that zigzag line that goes here between the metals and non-metals. That will be discussed later on in the course. So metals will always be positive, non-metals will always be negative. If I write that out now, you could actually learn that the group number and the charge. What you should do is make yourself a table. So for example, group number versus charge. You could make a table. So group 1, 2, 3, 4, 5, 6, 7, 8. Then the charges, you could learn them underneath. So +1, +2, +3, +4, slash, you don't need to worry about it, -3, -2, -1, 0. So with this powerful tool, you can work out the charge that any atom would form. Now, there are certain ones that you should learn, and I will show them to you now, and they'll be on the worksheet. So here is the worksheet that I'm going to use for some examples of how to solve these. So if we start first with which ones to learn, okay? For the positive ions, the cations, some metals, such as transition metals, can have multiple charges. So they will usually be shown to you in Roman numerals. So 2 means 2+ or +2. 3 means 3+. Now, lead, on the other hand, at GCSE level, you should just know it's +2. They might not give it to you. Same with silver, it's +1. And same with zinc, it's +2. So I suppose the ones you need to learn are the zinc, the silver, the lead, the 2 ions, even though the Roman numeral should tell you what it is. Also the copper, because copper is 2+, +2. Hydrogen, you might forget, it has technically got 1 electron only, so it would lose 1, so it's +1. You can work it out, but I would learn it. And the last one is this. Now, this is a polyatomic ion because it has more than 2 atoms. So when you see 2 capital letters, that's the ones you would usually have to memorize. So an ammonium ion has 1 nitrogen, 4 hydrogen, and it's a charge of +. Now for the anions, the negative ions, this was cations. Cats are good, cats are positive. You would need to learn carbonate. Hydrogen carbonate is more unusual, but you can't work it out really at GCSE. Hydroxide, very important, nitrate, and sulfate. So it's just 5 of them. Now, when the ending is 8, it means it contains oxygen and 3 different elements in total. So for example, magnesium carbonate would form a compound here with the carbonate. Watch out, when it's sulfide, it means 2 different elements. That's why it's in group 6, so it's -2. Sulfate, on the other hand, is 8, so it has the oxygen. So it's SO4 minus, nitrate NO3 minus, hydroxide OH minus, hydrogen carbonate, unusual nowadays, but still HCO3 minus, and carbonate CO3 minus. You can actually derive this because you see it's got CO3 and it's got an H. So because H is +1 and this is -2, 1 minus 2 makes -1. So you can actually work that one out. So that's a summary of what you need to learn. Now, when it comes to applying it, I will show you some examples. It's kind of 3 different levels of difficulty with these questions. If we start with the most basic example, sodium chloride. I'm going to show you something called the crossover method. So sodium is Na. It is in group 1, so it's +1. So you don't need to put the 1. Chloride is in group 7, so it's -1. The aim is to make a compound that's neutral. So how many of these do I need to make it add up to 0? Well, they can react in a 1-to-1 ratio, which means just NaCl. That is called an ionic formula. When it comes to there being different charges, say lithium oxide, we have Li, which is in group 1, so it's +1. Oxide is in group 6, so it's -2. Or you can see it here, 2-. Remember, it doesn't matter where you put the minus, before or after. Now, if you cross these over, what you do is you cross over the charge as a number. So you don't copy the plus, but you copy the 1. So the 1 goes here, and this 2 goes here. Then you read downwards. There are 2 Li's, so I write Li subscript 2. And there's 1 oxygen, so I write O1. But just like in maths, we don't put 1x, we do not put the 1. So it becomes Li2O. Some people like to think of it, I need 2 positives to match the -2. So they would just write Li2O straight away. It's up to you, but I prefer the crossover. So that was the easiest example. That is kind of the second level. Let me show you copper carbonate now. So copper carbonate, Cu, you can look it up, it's 2+. And carbonate, 2- or -2. Now, if you cross these over, the 2 goes here and the 2 goes here. And you end up with 2 of each. But when it's 2-to-2, the simplest ratio would be 1-to-1. So you actually just need 1 copper, Cu, 1, and 1 CO3. Now be careful. The 3 stays. The whole thing is multiplied by 1. So you do not need to do anything. You just leave a Cu, CO3, because there's 1 of the CO3 and 1 of the Cu. Now that can go to one more level of difficulty where we need to actually multiply this by something. So if we take zinc nitrate as an example, okay, zinc nitrate, I'll write it up here. Zinc is 2+. Nitrate is here, it's NO3-. Now you need to learn these. So when you do this, you cross over, the 2 goes here, and remember there's a 1 here, the 1 goes here. That gives you 1 zinc, you read downwards. We don't need to put the 1. But then people get confused with the 3 and the 2. They think, what do I do? Do I times it? Do I double it? Do I add it? So what you do is you think that the whole NO3 has to be repeated twice. So you put a bracket NO3, then you put a subscript 2, because that means ZnNO3 twice. 2 of the -1 makes -2, plus 2 makes 0. So that's kind of the harder types of example. I shall do one more. Aluminium sulfate. So Al is +3. Sulfate is here, SO4 2-. Don't get confused. Cross the numbers over. The 3 goes here. The 2, not before, the 2, the superscript, goes here. Then you read downwards, Al2, so you write Al subscript 2. Then the whole SO4 has to be put in brackets because there's 3 of them. If it was just a 1, you don't need the bracket, but it's SO4 3. So this will be the hardest type of situation you can really get at the GCSE level. So I suggest you practice through the worksheets, and there will be answers, and work your way through it. This is one of the fundamental concepts that you need to know. Otherwise, you can't really construct equations in chemistry. So good luck. Next lesson, we will use this to form ionic bonding. The first type of bonding we're going to learn is ionic bonding. And then we will cover covalent. That's the end of this lesson.